Hello, I am JD and you're listening to The Ongoing. This episode is about an experiment that measured gravity between ordinary objects, just pieces of metal sitting quietly in a room. Until this experiment, gravity was understood through its effects. And it worked remarkably well as a theory. But there was one thing no one had ever done. No one had measured gravity directly between ordinary objects here on Earth. There was no experimental number that told us how strong gravity really was. This experiment changed that. This is the story of Henry Cavendish and the experiment that made gravity tangible. The experiment he performed would later be called weighing the Earth, because his measurements made it possible for the first time to calculate how massive our planet is. By the late 18th century, gravity was not a mystery. Isaac Newton had given scientists a mathematical rule that explained it. That rule accounted for falling objects, for the moon's motion around Earth, and for the elliptical paths of planets around the sun. Newton's rule said three things. First, every mass attracts every other mass. That attraction is what we call gravity, the gravitational force. Second, how strong that force is depends on two things: how massive the objects are and how far apart they are. Third, Newton's law also contained a constant number. That number would later be defined as gravitational constant. And without knowing its value, the strength of gravity could not be determined in absolute terms. And this is where scale matters. The gravitational pull between Earth and the Moon is strong enough to keep Moon locked in orbit for billions of years. But shrink the masses down to the objects you can lift with your hands, and the same force becomes unimaginably small. Between two ordinary objects, gravity can be hundreds of times weaker than the faint touch of a falling snowflake landing on your skin. Gravity was powerful on cosmic scale, but almost impossible to notice between everyday objects. And measuring that was what Henry Cavendish set out to do. Henry Cavendish was an English natural philosopher. He was known for his careful and highly precise experimental work. Cavendish built his experiment around an extremely sensitive device called a torsion balance. A thin horizontal wooden rod, about 6 feet long, was suspended from the ceiling by a very thin wire. At each end of the rod, Cavendish placed a small lead sphere, each weighing about 1.5 pounds. He also placed two much larger lead spheres, each weighing roughly 350 pounds, very close to the smaller ones, but never touching them. The only force acting between the spheres was gravity. Once the apparatus was set, Cavendish could not touch it. He could not stand next to it. He could not even enter the room. Any movement, a footstep, a draft of air, even body heat, could overwhelm the tiny effect he was trying to measure. So Cavendish set the experiment in motion, then stepped away. When the large lead spheres were positioned close to the smaller one, gravity began to act between them. The smaller spheres felt a sideway pull toward the larger masses. Because the smaller spheres were fixed to the end of the rods, they couldn't move toward the larger ones. Instead, that sideways pull caused the rod to rotate slightly, twisting the thin wire from which it was suspended. The twist was extraordinarily small, far too small to see directly. So Cavendish remained outside the room and used an optical system, a telescope, and a magnifying setup to measure the motion from a distance. Each time the large spheres were brought close, the wire twisted by a tiny but measurable amount. From the tiny twist of the wire, Cavendish was able to measure the gravitational force between two ordinary lead spheres. He then compared that sideways gravitational pull to the downward pull of the Earth on those same small spheres. And from that comparison, he calculated the mean density of the Earth. That is what Cavendish published in 1798. He did not publish the mass of the Earth directly. He published its density. And his results were extraordinary. Cavendish found that the Earth's density was about 5.48 times the density of water. Today, the accepted value is 5.51. That is an error of less than 1%. Using the density and the known radius of the Earth, scientists were able to calculate the mass of the entire planet. About 6 million trillion kilograms. A number so large it's hard to grasp, built entirely from a force barely detectable on Earth. And hidden inside this experiment was something even deeper. At that time, the idea of a universal gravitational constant did not yet exist as a named concept. But Cavendish's measurements contained the information needed to determine it. What began as an attempt to measure gravity between two small objects quietly became the foundation for understanding gravity everywhere. What stays with me about this experiment is how much effort went into measuring almost nothing. Cavendish trusted that even the weakest forces would speak if enough noise was removed. And maybe that's the lesson beyond physics. Not everything meaningful arrives with impact. Some things only reveal themselves when we slow down, step back, and let the system settle. Gravity was always there. It just took extraordinary patience to notice it. Thanks for listening. I am JD and this is The Ongoing.